Hello folks, this is 2021 October-November paper 2 and the question number is 6. This question is concerned with the chapter current electricity. It says that a cell of electromotive force e.m.f 0.48 volt is connected to a metal wire X, this is the X, as shown in figure 6.1. The cell has internal resistance shown here. The current in the cell is 0.80 amperes, so shown here, and we can show the same here as well, 0.80 amperes, and here also it is 0.80 amperes. The wire X has a length 3.0 millimeters, so its length is 3.0 meters. Cross-sectional area is 1.3 into this much, and resistance is 0.40 ohm here. So the first thing is we have to calculate the charge passing through the cell in a time of 7.5 minutes. So the first of all, the time here is 7.5 minutes, and that's equal to 7.5 into 60 seconds. Then this gives us the value of charge is equal to I into T, current into time. The current through the wire is given as this much, so it is 0.80 into 7.5 into 60. So when I do the calculation, so 0.8 into 7.5 into 60, so that becomes is equal to 360 coulombs. So it is 360 coulombs. Then calculate the percentage efficiency with which the cell supplies power to wire X. So we have to find the efficiency with which it supplies power to X. So for that, first of all, we have to go for the power given by the cell. Power given by the cell. That's equal to the e.m.f into the current. And the value of e.m.f is 0.48 volts, and into the current given by it is 0.80. And that becomes, so 0.48 into 0.80 equal to, it is 0.0384 watts power. And the power obtained by X will be equal to the P, we can do as a V into I, but since the data is available is current, I'll do this as I squared into R of this X. And that will be equal to, the current flowing is 0.80 squared into R of X is equal to, given here as 0.40. So this becomes, so 0.8 square into 0.40. So this becomes equal to 0.256 watt. Now the efficiency is equal to power in X by power given by the cell, and that's equal to 0.256 divided 0.384. That becomes equal to so 0.256 divided 0.3 equal to, it is equal to, it is 0.66666 percentage, sorry, in fraction here it is 66.6666 percentage, and in 2SF it will be equal to 67 percentage. So it is simply 67 percentage. So since we have to write this in 2SF, we have converted it in likewise. Now the remaining questions. It is said that there are 3.2 into 10 to the power 22 free electrons contained in the volume of wire. So this wire has got this much amount of free electrons. So for X, calculate the number density N of the free electrons. So the number density N is equal to total number of electrons by the volume. So I have written a different V for the volume. It is not the same as the symbol for the potential difference. So that's equal to, the number is 3.2 into 10 to the power 22, and the volume is equal to area into L. That's equal to 3.2 into 10 to the power 22 whole divided, the cross-sectional area A is given here as, this is A and this is L. So it should be, it is 1.3 into 10 to the power 7 into the length is 3.0 equal to, so when you do the calculations here, again it's the calculation, so it is 3.2 exponent 22 divided bracket 1.3 exponent 7 into 3.0, very close, equal to, so this becomes 8.2 into 10 to the power 28 electrons per meter cube. So it is 8.2 into 10 to the power 28 per meter cube. Now comes the average drift speed. So its value is equal to V equal to I by NEA. NEA, we have all the values here. The value of I is, once again, the value of I is equal to 0.80 ampere. So it is 0.80 whole divided. N is, just determine 8.2 into 10 to the power 8 into E is 1.6 into 10 to the power minus 19 into A, the cross section is, again, once again this value here, it is 1.3 into 10 to the power minus 7. So 1.3 into 10 to the power minus 7. So here also we have got minus 7 here, okay, equal to, so let me do the calculations. So what it gives here is 0.8 divided bracket 8.2 exponent 8 into 1.8 exponent minus 19 into 1.3 exponent minus 7, very close, equal to, so this becomes equal to 4.69 into 10 to the power minus 4 meter per second. So when I write in 2SF, it is 4.7 into 10 to the power minus 4 meter per second. So it is 4.7 into 10 to the power minus 4. Now the last question, always the thoughtful one. So last one says a wire Y. So the initial wire is X here. This is wire X. Now it calls for another wire Y. Has the same cross-sectional area as X and is made of same metal. Wire Y is longer than wire X. So that means the length of Y is more than length of X, which means that is I dot E, length increases. Wire X in the circuit is now replaced by wire Y. Assume that the wire Y has the same temperature as wire X. So it is for ease, because when temperature varies, the resistance also varies. So it has reduced the effect of that temperature. State and explain whether the average drift speed of the electrons in wire Y is greater than, same as, or less than that in wire X. So let's do that. This means that R now increases because R equal to rho L by A. So A is same here. Rho should be same because temperature is same. So only thing is L changes. That's why R changes. R increases. Now if R increases, then we must have the current. The current now decreases. It's because we have got, it is because I is equal to E by R of X plus the internal resistance here. So we have got to go through the circuit here. The value of I should be equal to E divided by the total resistance of the circuit, which is equal to R X plus R. So I decreases. Now if I decreases, so therefore V equal to I by NEA. Everything is same here, only I changes, so that's why this also should decreases. So this means the new drift speed will be less. So that is a new drift speed should be less. So this is the answer to this question.